Good morning, ladies and gentlemen, and today we're going to be talking about computing limits with simple functions. Now, this is a pretty involved thing, computing limits. We'll be spending a couple days, probably about a week or so, on different techniques. Today, we're just going to start off with some of the basic ideas, or what we like to refer to them as basic limit theorems. At any point in time, you might want to pause this and copy these down in your notes. They're the concepts that allow us to do everything that we are about to do. They're the rules for us mathematically. All right, you can pause now. All right, so now you're done unpausing. So basically, I want to point out a couple things, what this is saying, what the limits are saying. Notice that both of these guys are A. That's saying as x is going to A for both different functions. One goes to one value, we call it L1. The other one goes to another value, we call it L2. And if you're adding and subtracting the functions independently and evaluate the limits versus doing it together, I just said those words backwards actually. You were doing it together here and independently here. It's the sum of the limits. The limits of the sum is the sum of the limits. It's kind of like a weird thing to say. And if you're multiplying two functions together and evaluating their limit, it's the same thing as if you're evaluating them independently and multiplying those values together. You could say the same thing with division. You're just dividing the values. The thing is, you make sure that L2 cannot equal 0 because you can't divide by 0. And finally, if you have any kind of root, whether it's a square root, a cube root, fourth root, whatever it is, you're just going to take the root of that value. Now, you might be looking at this and go, what's going on? This is really kind of confusing looking. Well, these are the explanations that allow us to do what I'm about to show you here. So let's get right to it. And I'll start just showing you. And then some of you will figure it out. So there's a couple different situations we could be looking at. We could be looking at situations where we don't know the functions at all. I just call them f and g. Those are two different functions. I don't know much about them. The only thing I really do know is the limit as x approaches 7 of the function f is going to a y value of 3. And as I approach the same 7, again, it's important these values are the same. And if they're not the same, you can't do the problem, but you're not going to have that situation. But limit as x approaches 7 of a different function, g, has a y value of -4. So the limit as x approaches 7 of 2 times f minus g. Well, 2 times f, the value for f is 3, so you're talking about 2 times 3 minus, and the value for g is -4. And I believe that is 10. All right. So here, let's look at another one. This time we have a square root. You can take the square root of some function f. Don't know what the function is, don't care. But I do know as x goes to 7, f of x is going to 3. So this is the same thing as the square root of 3. And finally, I think at least on this slide, as I'm going to 7 of f divided by g, that is saying 3 divided by -4, -3/4. So if you're not given a function, you're just going to take the values. Oh, I got one more. I forgot about that one. Now there's the square root of g. G is going to -4. So you have the square root of -4. Problem here. You guys know that this is imaginary. Well, if it's imaginary, like most of your friends, it does not exist. Do you remember that? It does not exist. So we can have times where these limits also do not exist. All right. Boop. Now, sometimes you have the function, which is really kind of nice. Now, both of these functions, I think there's just 2 of them. Yep, both of these functions are just polynomial functions. And the beautiful thing, I refer to them as basic functions. All you need to do is to plug in like it says. So you would have 2 squared minus 3 times 2 plus 4. So that would be, I believe, 2. Do that right. 4 minus 6 plus 4. Yeah. And in a similar way, you can do the same thing. 3 times negative 4 to the 4th power plus 10 times negative 4 minus 11. And you can do that as well. And where did my calculator go? So 3 times negative 4 to the 4th. I got 717. You could check the answer on your own. I think that's what it is. Looks good from here. Okay. So if you don't have the function, you have a little bit of information, you can extrapolate that and just plug in. Here, if you have the function, just plug in the value in question. Notice we plug the 2 in for x. Here we plug the negative 4 in for the x, because that's what they do in the function. Now, sometimes you'll have to look at a graph to kind of determine information. That graph will give you what those y values are. I'm going to let you have fun with those graphs when you take a look at the homework assignment. There's one question that deals with that. I don't want to talk about it too much. Just want to see if you can figure it out. We can also have trigonometric functions, but we're going to spend a lot of time with certain trigonometric functions because some of them are kind of weird. But in a situation like this is still kind of basic. Sine of theta, theta is going to pi. So it's the same thing as the sine of pi, and you need to know what the sine of pi is. And if you don't know what the sine of pi is, you need to look it up. All right, down here, let's see what happens here. Let's see, just plug the 5 in. You're going to get 5 squared minus 25 over 5 minus 5. And, oh my gosh, that's not just 0, but that's 0 over 0. Now, 0 over 0 is a special number. It's what we refer to as indeterminate. You can't determine what it is. All right, 0 over 0 is not the same thing as undefined. It's not the same thing as 0. If 0 is just an enumerator, you'd have 0 as an answer. But look at the function itself. Is there anything else that we could do to it? And the answer is yes, we can. This is why we learn these things in Algebra 2. Or earlier this year when we played with some of these rational functions. That's what they're called, rational functions. We're going to spend a whole day on them. Or like a 10-minute video, I should say. All right, now if I factored out the top, oh, look at these. The p minus 5s cancel each other out. Now if I replug back in, I get 5 plus 5, which equals 10. So if you get 0 over 0, today I'm going to tell you to try to factor. Okay, that's all I have to say. Now go ahead and try the work.